So we're going to run two tests, one with a noise source on and one without. We have extremely high signal to noise ratio. The Wi-Fi unit is about 2 meters from the current location. As you can see, we have fairly good internet speeds at this moment, and we have no noise source connected. In a few minutes here, after this first test, we will compare that same test to a test with the noise source connected and see if there is a difference between the two and if the cancellation pattern changes. So it looks like we've got an average upload rate, if you can't read that, of 28 megabits per second, or download rate of 28 megabits per second, and upload rate of 10.7 megabits per second. Let's rerun this test with the noise source connected and see what happens. Okay, the noise source is plugged in, and let's restart the test with the antenna pointed at the cell phone. Okay. So we are testing the ping. Fairly decent ping rate, but you can see there's a substantial decrease in the internet speed. We are running right now at 0.86 megabits per second, 0.7, 0.6, 0.5, somewhere in that realm. Let's see what happens with the upload rate. It's going a little slower due to the network communication issues. So the noise source is strong enough, even at this distance, with about a 20 to 25 dB rise in the noise floor, to kill the communication system. So we can see the effect of noise even on strong signals. We'll rerun this test in a moment to see if a different separation, closer base station, will change the results, hoping to decrease the cancellation pattern. So here we will run the test again, and we have an increased separation between the noise source and the phone. And first we will run it without the connection, or without the noise source. As you can see, it's the same as before, around 30 megabits per second for the download. Next we will go to the upload test. Download test is finished with an average rate of 29 megabits per second. Now we're doing the upload test. We're uploading at 31 megabits per second. Pretty constant. And let's see if this increased separation between the noise source and the system just decreases the cancellation pattern. So now I will plug in the noise source. The noise source is plugged in, and we will rerun the test. Testing the ping. Maybe I need even further separation between the two. No network communication. Alright, we'll try this again. And now we will try again with further separation between the noise source. And I'm going to plug in the noise source now. The noise source is plugged in, and let's see if further separation reduces the cancellation pattern. Yay, okay, so we can see a significant reduction. We're about equidistant between about a triangle of about a meter between each system, and we can see that our speeds are significantly reduced due to cancellation pattern changes. We have an average of 2.1 megabits per second download and a 3.8 megabits per second upload. So thank you for watching. That is the effect of noise, which does not breach the signal to noise ratio required by the communication system for 802.11. And as we can see, when the noise floor is increased, the constellation pattern of the transmitted symbols changes, and thus the speed is reduced in order to obtain a better signal to noise ratio. Thank you.